Hello everyone, I'm Kriti Gupta. In this video, we will be studying about insertion in a singly linked list. The content for today's topic will be insertion at the beginning, insertion at the end of the singly linked list, insertion after a specific position of a singly linked list, and how to calculate the length of a singly linked list. Okay, first we start with the insertion at the beginning. Insertion operation means already have a linked list and we are inserting a single node in a singly linked list. Okay, now to insert a node, first we need to create a node. Node creation can be done from malloc function by using malloc function or by using a calloc function, so which we have already done in the previous lecture. Now to insert a node at the beginning of the list, what we need to do, we have created a node. Suppose we have created a node p, this is a node created. We will be storing a information part in this particular info field. Now we know the next field of a node contain the address of the next node. So what will be stored in the next field? Now we have to make this node as the first node. Insertion at the beginning means we have created a node and now we are inserting this node at the first position. Beginning means inserting at the first position. So we know that a pointer variable start always contain the address of the first position. So if a linked list is already present over there and start contain the address of the first node and you are inserting a node at the beginning, you're making another node as a first node, so the previous node will become the previous first will become the second. Okay, so now this new node which we are inserting will then this new node next field will contain the address of the previous start previous node which is pointed by start. So we have stored p next equals to start. Now as this new node has become the first node, we will update the start pointer. Now start will start pointing to this particular node, so start equals to p. Let's see in a form of algorithm. To insert a node at the beginning of the list which is pointed by a start pointer, and we also have the data item that is to be inserted. First what we need to do, we need to create a new node. We have created a new node using a malloc function. Now we are checking whether the node is created successfully or not. Okay, if ptr, if the new node is created and the address of that particular new node is stored in ptr, so if a ptr equals to null means it does not contain any address, means nodes creation was unsuccessful, we will print the overflow condition and exit. But if this condition is false, that means that node is created successfully, we will update the info field of this particular node. We will set ptr info equals to item, the data to be inserted. We will now link this new node with the existing linked list. Okay, so we have set the ptr next as equals to start contains the address of the first node, initial first node of the linked list. So if we are inserting one new node in the linked list, the previous first will become the second. Okay, so we have update, we have set the ptr next equals to start, and then at last we have update the start always contain the address of the first node. So if we have inserted a node successfully, we have linked the node with the linked list, then we will update the value of start also. We now to convert this algorithm as a function, as a program, we have taken, we have struct node temp. Okay, ptr equals to, we are creating over here a node using malloc. If we want to create a node using malloc, we must pass the size, what size is needed to be allocated, created. Okay, so we don't know, if we do not know what size is there, we can use the size of operator. We have to create a node, so we have passed the size of struct node. This will calculate the size of the node. Malloc will create this much amount of allocate this much amount of memory and will return the void address. But we need address of type struct node, so we will be doing the typecasting. We have done over here typecasting of type struct node start. Okay, now let's just make this temp as ptr. Okay, so next we will be checking if ptr equals to null. We have created a node, address is stored in ptr, but if the node if the memory was is full, then operating system won't be able to allocate the node. In that case, instead of the address, it will have the null value. So if ptr equals to null means node is not created, it was an unsuccessful creation as memory was full, so we will print overflow and exit. Otherwise, if the node creation is successful, what we will be doing, we will be entering the node data, we will be storing the node data in a data field, and you can just set next field as null. We can check if start equals to null, then we will update start equals to ptr. Otherwise, if start is not null means linked list exists. Okay, in that case, the first node address which is contained by start will be linked with this new node next field. So ptr next field will equals to start. Next, we will update the start as the ptr because this node is inserted at the beginning. Now this new node is the first node of a singly linked list. This is the insertion of a node at the beginning of the singly linked list. Next is if we want to insert the node at the end of the linked list. Whenever we have to perform the insertion operation, first we need to create a node. Next, we need to check whether the node creation was successful or unsuccessful. If the node creation is successful, then we perform the insertion. Node is created, we will be initializing the data field of the this new node. Now next come the linking of the new node with the existing linked list. Where we have to perform the linking, it is insertion at the end of this linked list, so we have to perform this linking with the end of the list. So first what we need to do, we need to traverse from first node, that is from the starting to the end of the list. Once we reach the last node, now if we are adding inserting a new node at the last location, this last will become second last. So the link part the next field will contain the address of this new node, and the new node next part will contain, as this becomes the last node, so next part of this new node will contain the null value. Okay, let's see it in a algorithm. First, we have created a new node. We have checked for the overflow condition. If it is not an overflow condition, if this condition is false, and we have set the data part also, we have set the next part as null. Now we are checking if linked list exists or does not exist, in which we want to insert this node. If start equals to null means this linked list was empty, there was no node, and we are inserting a new node in a null list. Okay, so this first list will become the first node will become the last also. So if start equals to null, then we will set start equals to ptr and will exit. But if this is not the last node, then what we will be doing, we will be traversing from first node to the last node. So to traverse from first node to the last node, we will be taking a data one variable through which we can traverse, one pointer through which we can traverse from first node to the last node. So we have taken loc as a pointer variable through which we are traversing. We have to traverse from the starting node, from the beginning node, so we have initialize loc equals to start. Now we will be repeating, we will be checking each node whether you are last node, whether you are a last node. Okay, how we can we determine whether the particular node is the last node? If the next field of that particular node contains the null value. Okay, But if it does not contain the null value, then what we need to do, we need to go to next node. So we are repeating this step 7 until we reach the last node. So until loc next is not equals to null, what we are doing, we are going to the next node. If this condition is true, that the particular node next field is not null, then we are going to next node. So we have update loc equals to loc next. Okay, we have continued this step. Once this condition is false, that means loc next is equals to null, that means we have reached the next node. Then what we are doing, we are linking this last node with the new node. So the next field of this last node will contain the address of this new node. So we have set loc next equals to, the new node is stored with ptr, so loc next is equals to ptr. The function for this particular insertion is insertion at the end is also called as append function. Append means inserting a node at the end of the singly linked list. We have created a node using malloc function. We have entered the data at this particular node data field. We have set the next field as null. Now we are checking whether the linked list, then we will be checking for the overflow condition. If the overflow condition is false, then we will be checking whether the linked list exists or not. If the linked list does not exist, then this node which is inserted will be the first node as well as the last node. So we have set start equals to ptr. But if the linked list exists, then what we need to do, we need to traverse from starting node to the last node. Okay, so we have, for traversing we have taken a variable loc. We have set the first node address to the loc. Now we are comparing whether this particular node is the last node. So we have checked loc next, this node next part is not equals to null. If this is not equals to null, then we have to check for next node. So we have taken loc next not equals to null, so we are going to the next node. Next node address is stored in the next field of this particular loc. So loc equals to loc next. Now we are again comparing whether this field next field contain nulls. If it does not contain null, then loc equals to loc next, so we will be checking for the next node. Whether this field loc next contain the null, yes, it contains the null, so this from this node we will be out of the while loop. Loc next not equals to null, condition is false, we are out of the loop. Now what we are doing, we have reached to the at the last node. Now what is required, we just need to link a new node with the last node. New node address is stored in the ptr, so loc next is equals to ptr. We have linked the last node of a singly linked list with this particular new node. Okay, next is insertion after a specific position. Suppose this is our linked list. Okay, these are the elements stored in the linked list. Now we have to insert x after in between the third and fourth element. If we are doing the insertion after a specific position in an array, if we are performing an array, we need to do what, we need to shift all the elements by one from the position where we want to insert an element. We want to insert between third and fourth, so we will be shifting from this fourth position all the elements by one. Once we have created a space in the between, then we are storing that particular element at that particular index location. If we want to do same thing in a linked list, what we need to do is we need to go to that particular node. We will be starting from the first node and we will be traversing till we reach that particular location p. If we have already have the particular location p where we want to insert the node, then what we need to do is we will be creating a new node which is to be inserted. We have set the data field. Now we will link this new node with this linked list where we have to insert. See, we want to insert it after p. So after p, which node should become, this new node q should become, and after q, which node should come, the node which was previously pointed by the next location of the p. So what we will be doing, we will be setting the next field of the queue. Next of queue will be which was the previous next of p. So we have stored q next equals to p next. Now this q is pointing to this x3 node. After linking q next, now we will update the p next. After insertion, p next will be q. So now we have linked p next equals to q. We only need to update the two next field. Okay, and when we were inserting an array, we need to shift more than one element depending where we are inserting. Okay, so the time complexity required to insert after a specific position in an array is approximately n big of n, whereas time required to store after a specific position in linked list is constant because we need to only perform the two updation. Okay, we need to set two next field in a linked list. Okay, let's talk about the algorithm. If we are inserting an element, first we are creating a node, we are setting the info part, we can set the next field also as null. We will be checking for the overflow condition. If start equals to null, then what we are doing, if start is null, then we are setting start equals to ptr. Otherwise we will be taking a counter variable. Okay, why counter variable? If we are giving that we have to store the insert this particular node after a specific position, after a specific location, that after five nodes, then first we need to count the first node, second node, third node, fourth node, fifth node. First we need to reach till fifth node. To reach this fifth node, we are taking a counter variable. We have initialized this counter variable I. We have also taken a pointer variable to reach till fifth node. To traverse till fifth node, for traversing we have taken temp. Okay, we will be traversing from the starting. So initially we have initialized temp equals to start. Counting will be done from zero. When we will be reaching first node, we will count as one. So for counter variable, we have initialized I equals to 0 until we reach till the location which was required. What we are doing, we are updating temp with the next node, and we are updating the counter variable by plus 1. Once we reach the required location p, once we reach the required location p, then what we are doing, we are only setting the value. Okay, now this p is represented by what? Temp, and the new node q is represented ptr. So first we were updating the q next, so ptr next is equals to temp next. Once we have updated the q next, now we will be updating the p next. So the next will be temp next equals to ptr. In function also we are using the same thing. We have taken the temp variable, int location, length. Okay, we have entered the location. We have used the length function to check whether the location entered by the user is valid or invalid. That means if a singly linked list contain only 5 nodes and the location entered by the user is 12, then it is not possible to insert a node after 12th location. Why? Because this linked list contain only 5 nodes. To check whether the location is valid or invalid, we have first calculate the length using length function. Length means total number of nodes in a singly linked list. So if the location is greater than length, means it is an invalid location and we cannot insert a node after this particular location. But if the location is a valid location, then we have to reach to that particular location. We have started the traversing from the start node, and what we are checking, till we reach that particular node location LOC. We are updating the temp with the next node, and we are also updating the count I. Okay, once we reach that particular location which was pointed by P in the diagram, but which will be at the address of that particular node will be stored in temp over here. Okay, now we have created a new node. We have entered the data field at the data part. We have set the next field as null. Now we just need to link this particular new node ptr in the linked list where after temp. So we have updated the ptr next will equals to temp next. We have made the right connection. Now we will be making the left connection. Temp next equals to ptr. So this is the insertion of a node after a specific position. Next is the length of a linked list. Length of a linked list means total number of nodes in a linked list. Now, if you want to count the total number of nodes in a linked list, we for counting we have taken a count variable, integer count variable 0. How we can count? Whenever we are traversing from this first node. First node means from the starting node till the end node. How can we determine this node is an end node? If it link part contain the null. Okay, from starting to end we are counting all the nodes. So to traverse from starting to end we have taken a pointer variable temp. We have initialized it with start. Now till the linked list exists means till the nodes in the linked list exist, till temp is not equals to null, we are updating count by 1 and we are moving from one node to another node. How can we move from first node to second node? We by updating the this traversing pointer variable temp. Temp contain the address of the first node in start. Now we have counted that particular node, count plus plus. Now we have to move from this node to second node. To second node, the address of second node is stored in the next field of this particular node. So we have set temp next equals to temp. Now we have moved to the second node. We are checking whether the linked list exists or not. Linked list exists. Then again we will count this second node and we will move to the third node. Okay, now we have done temp equals to temp next. The third node address will be stored in the temp. We have again checked whether the third node present or not. If the third node does not present, if the linked list contain only two node, then temp will be equals to null. We will be out of the loop and we will return the count value which will be equal to 2. Okay, this was the length of the singly linked list. Thank you.